We can also use these trig ratios to solve for the unknown angle in a right angle triangle if we've been given two of the sides. So yeah, in each of these cases, we have two sides, and yeah, we should be able to solve it. It's going to require a little bit of reverse math, but that's inverses. We've talked about that. So for the first one, same idea. What we're going to do is go through and identify, with respect to that angle that we're interested in, what are the sides that we know about here. So if I look at this one, I've got my opposite and my adjacent. And so that should tell me to use tangent. And so I'm going to set up my equation. So it'll be not sine. Tan theta is opposite over adjacent. Tan theta is 111 over 92. If you want, you can get a decimal for that, but make sure you keep several places. You'll run into problems if you round it too much. So we get a 1 point, let's say 2065. I'll keep 4 every time. Okay, so what we're trying to do though is solve for this theta. So we need to get rid of the tan. So we need to undo tan. And as we know, we undo operations by using their inverse. And so your calculator should have these inverse operations, and they're sometimes written as tan to the -1. So it's not 1 over tan, it's saying the inverse of tan. And so what I'm going to do is apply that to both sides. Tan to the -1, tan to the -1. And the point is that on the left side, those two things are going to cancel. And what we're going to get is theta is tan to the -1 of 1.2065, roughly. Again, I did do a little bit of rounding. And so as far as punching that in the calculator, typically to get to these inverse functions, you need to use like a shift or a second key. Just depending on what your calculator looks like. And then you'll hit the tan button. It's probably, you'll find that tan to the -1 as sort of the secondary function to that button. And so that shift will get you to that secondary function. And then you punch in your number, hit equals, and hopefully that gives us an answer. Let's see, second tan 1.2065. And so I'm getting theta is 50 let's say 3, I'll use one decimal place here, 50.3 degrees. And so that's what we're going to do for all of these. So the second one, what we've got is my opposite and my hypotenuse. So I'm going to jump right into this one. We want sine. So sine theta is going to be opposite 5 over hypotenuse 13. So round that with a bunch of decimals, 0.3846. And I'm going to use that inverse function for the theta. So sine to the -1, 0.3846. And again, if you're not in the right units, if your calculator doesn't have a little d or degree somewhere in it, then you're probably in like r or radians or g gradients. We don't want those. If you don't have the right units, you're not going to get the same answer as me. So I'm going to do sine to the -1, 0.3846. And I get about 22.6 degrees. All right, the last one, set this up. I should have, this is my hypotenuse. And process of elimination, this one's probably cosine. So cos theta is 42.1 over 70.3, about 0.5989. And so I'll use my inverse cos. And I don't like this calculator. It's not easy to use. There we go. Oh, 53.2 degrees. All right. So yeah, that's basically how we'll use these inverse actions. There's not really any trick to it. You just have to get familiar with using the inverse cos, inverse sine, and inverse tan. It is worth noting that sometimes you'll see them written a little bit differently. So the inverse sine function, if I have sine to the -1 of a, this is sometimes written as arc sine of a. And similarly, cos to the -1 of a is sometimes written as arc cos of a. And tan to the -1 of a is sometimes written as arc tan of a. Basically, because that raised power -1 it's a little ambiguous. Like if that means, does it mean a power or does it mean something else? And the problem is in different cases, it means different things. So the arc sine, arc cos, arc tan are a little bit cleaner, but they're less commonly used. So just be aware that those are the exact same thing.